so much for that. I just forgot I gotta put my chair back. Okay, so I appreciate the opportunity, everybody. Let me share my screen here. Ta-da! Okay. Good stuff. All right, good stuff. So how much time do we have, by the way? Like an hour?
An hour.
Okay, starting from 9 after, whatever. We'll go an hour. Okay. Well, I appreciate it, everybody. Thank you so much for coming. I'm very happy to see you all of you. We don't have a lot of time. We have about an hour, so I'm going to go pretty quickly. There's a lot of stuff to cover, but a lot of interesting things to look at, a lot of things to focus on. But before we get too far down the road, I want to draw your attention to this slide. This slide is hopefully going to be the most important slide you see in the next hour. Now, of course, there are that assumes that you stay in this presentation, right? I am Josh Long. I work on the Spring team. I am a Spring developer advocate, a Kotlin Google developer expert, and a Java champion. And of course, my email is there and my Twitter is there. So should you have questions, when ineluctably you have questions, do not hesitate to reach out to me. I'm at your service. And of course, the code that we're going to look at is there. All that you need is on the Git repository there. So we're going to go through a lot of stuff. And I love, as you can see by all this, by all the little titles there, I love software. I love open source software. I love the JVM community. I love Kotlin. I love Spring. I love Java. I mean, all these things are awesome. And so as part of that, I've done training videos on Safari. I wrote a book a few years ago called Cloud Native Java. This book is all about how to build applications that survive and thrive in the cloud. I have a podcast called A Bootiful Podcast. And this podcast is just me every Friday talking to people. And I also do a blog every Tuesday. This is called This Week in Spring. It's just a roundup of all the news that's fit to reprint in the ecosystem. And of course, every Wednesday for seasons, I have different seasons. I do a video, right? So I do all these different things out there. Okay, sorry. I'm sorry, by the way. I'm sorry for being late. I was trying to log in. I had a Google Meet in my spreadsheet. My assistant Beth and the event had coordinated, and I tried to log in, and I couldn't get that, so I went a long way around and got logged in. But now I'm getting messages from her trying to help me get logged in. It's fine. So anyway, I do this thing called Spring Tips. It's a playlist of YouTube videos every Wednesday. When I do them, I do 11 episodes at a time, and then a wrap-up episode, and then take a little bit of break, produce new content. And so the next season, I don't even know what season it is now, 6, 7, something like that. The next season will be 11 episodes on Spring and Kubernetes. So join me for that. And of course, I've got a book that I just did called Reactive Spring, and this just came out 2 months ago. You can buy it online on leanpub.com, or you can buy the printed version possibly in your markets, in Amazon as well. So it's a book about how to take advantage of reactive programming. And so what we're going to talk about today kind of benefits from reactive programming, but we're not, strictly speaking, going to assume reactive programming. We're going to talk about Kotlin. I love Kotlin. This language has become something very interesting to me because it has grown and grown and grown, and it has become very popular. And personally, I've only been using it since 2014, okay? I think maybe a little bit earlier than that, but basically in earnest since 2014. So by that point, it was already pretty mature. It had already been around for 4 or 5 years, and people were using it. And I started giving presentations on it, and I started showing people how to use it with Spring and so on at that time. A few years later, the Spring team on which I work added support at start.spring.io for generating brand new projects using Kotlin. And this is really a big deal because it meant that a lot of people that were using Java now had an easy way to start building Kotlin-based, Spring-based applications. Very exciting. That opens up the community. You know what else happened that was very interesting? In 2016, I was invited to speak at Kotlin Conf, the very first Kotlin Conf event. And this event was going to take place in San Francisco. I live in San Francisco. I'm not sure if you can see much out my window there. It's getting darker as we speak. But I live in San Francisco in the west coast of the United States. And I love coming home to San Francisco. San Francisco is a nice place to come home to, I guess. There's lots of nice places in the world. This is one of them, right? And so it used to be that I traveled. I used to travel a lot because, before the coronavirus, right? So before the coronavirus, I would travel 650,000 miles, or more than a million kilometers every year, right? On planes, visiting countries all around the world. And I was excited. I was excited to come home and spend time home with my family and have time to go to this conference and speak with other Kotlin enthusiasts, people who like the language like I do. And I thought, well, this is going to be great. Thank you so much, Hadi. Thank you, JetBrains, for inviting me to this conference. The very first one, I'll be there, no problem. Sign me up. And so I didn't think much of it, right? Because this is, he's inviting me to speak in 2017. This is back in 2016, right? So we had 6 months, at least maybe a year to go before the actual event. Finally, the event arrives. It's time for the event. And something interesting has happened. You see, between when Hadi invited me to come to this conference, this tiny little conference with this brand new language that was very early, before he invited me to come to that conference, he made one quick appearance at Google I/O. And at Google I/O 2017, Google said that they formally support the use of Kotlin in the Android ecosystem, very much like Spring supports the use of Kotlin in the Spring ecosystem. And this was huge because in the Android ecosystem, there were already many different people using Kotlin to great effect. Obviously, Jake Wharton over at Square is somebody who's very famous and very visible for having helped people move to Kotlin on top of Android, right? And there's a lot of good reasons that Kotlin has dominated the discussion in the Android ecosystem. It is a very, very nice language, kind of like Java 30, right? But it also has the ability to run on much older JVM versions. So that's great for Android when you want to run on something that's older, right? So it's just a very interesting opportunity to be able to get the best of both worlds. Nice, clean, elegant language, but still get backwards compatibility, which means that if I'm building an Android application, it'll work just fine across different versions, right? Very interesting to me, very interesting to me. And so obviously, huge community had built up around it. And now here is Google, and they're saying, yes, we welcome Kotlin. Very, very interesting to me to see that. So I'm thinking, what is this going to mean for this conference? I get to the conference, this little conference, first one, no marketing basically, and I get there and there's 1,500 people. Crazy, that's incredible. It's wonderful. Huge crowd, great audience. People love the language. It's an energetic show. I was so excited, right? And then I start to realize, oh wow, this language that I love, everybody loves it. It's a really pragmatic language. And so the question is, why has it grown so successful? For me, I think from what I just said, I hope you can kind of see where I think a lot of the success has come. It's because it has already had very good success in different communities. And it has had that good success because of two things. First, the team that works on the language, the Kotlin team over at JetBrains, they're very pragmatic. They're very accommodating. They want the language to work well in their in as many communities as possible. And so they have done as much as possible to make that the case. And then two, the different ecosystems that are out there have recognized the opportunity that Android provides or implies, and they have worked to make it a part of their community, right? So the Android ecosystem brought in Kotlin. The Spring ecosystem brought in Kotlin, and so on. And so this has created a very wonderful, virtuous cycle where you get more people who want to use it, and more people who can use it, and more people who want to use it, and so on. And it just gets bigger and bigger and bigger. So now Kotlin is the #2 largest language on the JVM after Java itself, and it's growing, right? The trajectory is much higher than Java. And even more telling, and by the way, I don't mean to, let's just be clear here, the numbers are not yet at a place where you could say it's a threat to Java or anything like that. It's not, but still, it's growing at a large amount. It's already the #1 most popular secondary language after Java. And you can see that, right? There's jobs that advertise it. There's whole companies that do all of their software in Kotlin. There's, and the other thing is that the team that works on Kotlin has worked very hard to expand all the possible uses of Kotlin. So now, today, in 2020, almost 2021, you can write software that uses Kotlin for native code, Kotlin native, right? You can use it for Android, for mobile phone applications. You can use it, and by the way, that Kotlin native, you can take that Kotlin native code and compile it to WebAssembly, right? So now it runs in a browser at lightning speeds. You can also compile Kotlin code to JavaScript using Kotlin.js. You can also run Kotlin code in your build files if you use Gradle. You can also run also build your Spring Boot applications, your server-side JVM applications with Kotlin, right? So now you have the ability, if you want, to be a developer that does everything entirely in Kotlin. Kotlin can be a better Go, a better Rust, a better C++, a better Java, a better JavaScript, a better Groovy, a better whatever, right? It's just a very interesting language now. And that Kotlin multi-platform possibility is just another example of the Kotlin team working really hard to make the language as accommodating as possible. They're not trying to provide one language that runs identically across every platform. That would be impossible and also not useful, right? Because you would have to make so many concessions, so many compromises in each individual domain that the result would be less than desirable. But what they have done is they've tried to provide a Kotlin that works as best as anything can in these respective domains. And so that, my friends, I think represents the most pragmatism, right? And there's also the possibility that you can mix and match. You could write your core business logic, your domain logic, in this cross-platform code, and then cross-compile it. You can use that business logic and the domain types in your JavaScript for your React or Vue.js applications. You could use it in your native code for whatever backend processing you need to do or whatever. You can do it, and you can use it in the server-side code for your database logic and your web service API, and you can use it for the mobile code, right? The same types. You store it once and you reuse it across all these projects. So that's a really interesting opportunity. So what I want to do is I just want to take a quick moment to kind of observe all of this in action. So one unique opportunity, of course, that I've talked about here is this idea of using it for Android, right? Now, Android is, very, very quick. This is Android Studio. It's by Google and JetBrains, right? So it's not just a JetBrains project, but it already shows you something interesting. I'm going to build a hello, and you notice that the language that we get here by default out of the box, it's not Java, it's Kotlin. The default language is Kotlin. So I'm going to go ahead and hit finish. We'll hit generate. Okay. And this will take a few seconds rather, I hope, to load. That's okay. Let me hide that. Good. Updating indexes. This part's always a little tedious. I wish this would be a little faster. Come on. I've just run this literally half an hour ago, so it's always slow. I don't know why. But once it's up, it's really fast, right? That's the thing that's important. Configuring, updating indices. You can see it's importing the Gradle project. Ayo. I hope the rest of our demo isn't like this. This is terrible. Okay, we're so close. So close, friends. There you go. Okay, so we have a brand new Kotlin-based application. It's just a very simple application. You can run this. I can run it in an emulator. Replace with my own action. This is a view. Replace with my own Bootiful action. Okay, and then restart this. And we should see that we've got a Kotlin-based application. So this doesn't tell you much about the language itself, but notice that it's easy. It's trivial to get started. And if you understand Java, this is already a nice opportunity. So we're going to let this run. This takes a few minutes sometimes to to start up. We'll let it do its work in the background there. The other opportunity is to use IntelliJ, right? And so IntelliJ is another tool by JetBrains. You can use the open source version or the professional, the ultimate edition. Either one will support Kotlin. And here you can build all sorts of kind of stuff. What I want to do is I want to build a native application, right? Okay, loading this. Excuse me. New project. Come on. It's really thinking very much. Okay, there we go. So I'm going to build a new project, and we're going to call this the Hello Native project, and I'm going to use a native application code. I'm going to choose a JVM, a JDK, Java 11 will be just fine. I'm going to choose Gradle Kotlin, right, or Gradle Groovy, but I'm going to choose Gradle Kotlin. I'm happy with that. And then we're going to hit next and hit finish. And in the meantime, hopefully this will come to life over here. Let's see what this is doing. There's something over here. There it is. So, hello first fragment, settings, blah, 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 right? So you've got, now it's loaded up twice, but it's okay, right? We don't care. Hello, okay, next, previous, action bar, etc., right? So trivial, not hard at all to get something already working. You can deploy that to your phone and you've got an application and it's in Kotlin, right? And you can now reuse the logic. And we haven't even seen the language yet. We don't even know what it looks like. All you need to know is that it is trivial to get started. There's no reason to not do it. It's free, right? It's easy, it's cheap, it's free. Okay, so let's close down these things, please. And this one as well. Okay, so now we have a Hello Native application. And what I want to do is I want to build an application that uses Kotlin native. So we've just seen how you can use Kotlin in the mobile space. Here is my build file, my Kotlin build file, right? Gradle, already very concise. It's not, it's a DSL for doing builds, right? So if you haven't seen Kotlin before, this is interesting. But I'm not even focused on that. What I want to do is write some native code. So I'm going to go to my main file here. And already we've got a little taste of Kotlin. First of all, it's a function. You can tell it because it says fun. Let me make the font larger here, friends. I just realized the font might be too small. 20, let me call it 30. Okay, so this is my function. And this function is going to write data. I'm going to read data from a file. So I'm going to create a file here. I'll say cd desktop echo hello file. Hello world file. So if I go cat file, I should see 2 lines, okay? Hello world. Now, I have a function, and this function is the main function. Normally, in most languages, there's an array of string, right? It's public static void main array of string in Java. Well, in this case, the language doesn't, I'm not using these arguments, so I don't have to declare them, but they are there. If you have the variable and you're not using it, right, then you can see the IDE is saying, hey, look, you've got these arguments, but it's never used. So you can just remove them, right? And the language doesn't care if you don't have that. This is a function. It doesn't return anything. You don't see a return value. If I wanted to, I could say unit. That's the equivalent of not having a return value. That's the equivalent of void, okay? It's one kind of void. And all I'm doing is I'm printing out a result. Now, what I want to do is instead, I want to create a simple function to read lines from a file path, right? And that path is going to be a string. And the results that I'm going to return are in a list of strings. So there's my function. And here, I'm going to return, I'm going to do to do, right? Need to read file path contents, right? So this is just a simple function. And you can already see I've got some interesting things happening here. First of all, what does to do do? Well, to do is you see the ID recognize it. It says, oh, look, you've got something special there. Notice that when I didn't have this, I got a little red error there. That little to do is a inline function that returns nothing. And I don't mean that it doesn't return anything. I mean, it returns a type called nothing. Nothing is also void in Kotlin. And so this language, when it's with the compiler, when it sees nothing, it says, oh, this function will never return. It maybe has an infinite loop. Maybe it's just going to block on something. Maybe it's just thread.sleep forever, whatever. The point is, it never returns. Maybe it's listening for data, right? So it's never going to return normally. And so the compiler can look at that and go, oh, you're not going to return normally. And so therefore, it's not possible for the user to get to this line, right? Right here, hello world. See, the compiler understands this is unreachable. And so because it's unreachable, it knows that this is going to, the only way that this function will exit is if you throw an exception or if, or if the application shuts down, right? So it knows that even though the return value is string, it's never going to get to the point where it needs to return string. You understand? And so that's very interesting. That's a difference there. At the bytecode level, nothing and unit are both void. They're the same as in Java, but the compiler understands one is different from the other and treats them a little differently here for our purposes. So that's very convenient. Now, what I want to do is I want to read data from a file. And that file, we've got the basic file there. We want to create we want to get a variable to ask the operating system where the home directory is. And I can use the standard POSIX function. POSIX, P-O-S-I-X, is a abstraction for talking to an operating system, right? It's the basic API, if you will, that a Unix-like operating system will expose. Linux, Unix, Darwin, whatever, expose. And so I want to use POSIX from my C code and from so many other languages. These functions are all fairly familiar. If you've never used any of these POSIX APIs, then you're going to be lost when you go into most programming languages. It's only in Java and .NET where we have rewritten everything, right? It's completely different based on the Java way, right? We don't use low-level APIs. So it's nice to learn POSIX so you can work with every other language, and it's nice to learn the Java way so you can work with the JVM ecosystem, right? And so these POSIX APIs do interesting things. The first thing I'm going to ask it for is to get the environment variable called string. The problem is this doesn't return a Kotlin string. It returns a C pointer, right? And the C pointer is not what I want. So what I want to do is I want to say, okay, give me a K string. Okay, well, we've got another problem. Look at that. The compiler is saying, whoops, you can't do that. There's a possibility that you're going to get a null value from here. And the compiler can check that for you. So I have to either tell it not to worry by yelling. I like to yell at my code sometimes. And in this case, that actually works, right? You can yell at it. Or you can ask the results. You can tell the compiler that if it's not null, then call this function. If it is null, then just return null. So here I'm saying, I'm not going to get a null pointer exception. I might get a null, but at least I know what I'm getting, right? I'm controlling how I get the results. So what if I do get a null? Well, I want to have a fallback value, right? So now here, this variable, if you look at this variable is equal to a string. But if I remove this fallback case, look at that. It's upset because it's saying, look, we haven't cared for the possibility that you might get a null value back. And because we haven't done that, this could be a null. So we need to make sure that the type system tells you that something is null. So question mark is null, non-question mark is not null, right? And so that's why I have this here. It's a fallback in case the value is null. So home will never be null anymore. It's guaranteed to not be null. It might be an empty string, or it'll be the result from home, but it'll never be null, right? Now we've written some very efficient code, very nice type-safe code. And the next thing I want to do is I want to read those lines from this path. So I'm going to create a string here, and I'm going to use the variable. I'm going to do some string concatenation. But again, this is native code. Obviously, this is just for the native code, and yet I'm doing these very high-level things. So I'm going to go to the desktop directory, and the desktop directory called file, right? That's the file I want to read. And so I want to get the lines, and I'll have lines, and I'm going to say, let's map each line, because remember, I'm getting back a list of string, right? So I can visit each line that I get back here, and I'm going to take each line out, and I'm going to say, okay, for each line, line.trim. Okay, well, look at that. That's a very Java way to write this code. First of all, in Kotlin, If you have a lambda, you don't have to have the lambda inside the function body, parentheses rather. You can drop those. And second of all, I've got a function, I've got a lambda here that has one parameter. Well, I don't need to express the whole parameter prototype list like that. I can just say it.trim. It is an implicit parameter. It's like this. This is redundant. You don't need to do this. But if you said it, then you drop this and it still works, right? It creates the implicit variable for you. So now I've got these lines, and now I just want to, I want to print them out. So I can say lines.forEach, print line it. Okay. So now you can see I've got what I'm going to do something with the data. Let's actually get that work done. So what I want to do here is I want to read the data, right? So I'm going to open this up with the path, the file path, and it's going to be a read operation. And then once I have that, I'm going to create a list, a mutable list of strings in which to store the results that I read from the file. Now, the thing is, I want to read the data from the file, but I have to use native POSIX APIs. And when I read from the native POSIX APIs, just like any other I/O operation on almost any operating system and platform, what I'm going to do is I'm going to create a buffer, a byte array. I'm going to scoop the byte array into the byte stream, pull the bytes out, and say, oh, okay, I've got 1, 2, 3, 4, so many bytes. I'm going to accumulate them into the larger list here, and then I'm going to keep doing that. Well, this requires me to create a manually, dynamically allocated array of memory, right? Remember, this is native code I'm writing here. There's no JVM code here, right? So I need to safely, dynamically allocate memory. And since that is using a native API, I also need to clean up that memory, right? This is one of the big pains about writing C code in C++. Somebody has to garbage collect. Something has to clean up after what you've constructed. Well, here, Kotlin gives you a very nice way to solve this problem. You can say memscoped, and then there you go, right? So now val equals 1024 times 64, okay? That'll be my buffer length. And my buffer is going to be an allocated array. Alloc array of, and it'll be a byte var, okay? So an alloc array of how long? This long, buffer len. Okay. So now I've got this dynamically allocated array, and what I want to do is I want to read the data from the file. So I say, while true, val next line equals f gets from the buffer len, and then the file, right? And of course, what does this give me? Well, it returns a thing that I need to convert into a k-string. So there's that again, right? And I say, okay, if next line should equal null, or next line is empty, very nice, see if it's just an empty string, then we quit, because we don't want either of those. We just want to keep it, right? So break. Otherwise, lines.add next line, right? So this variable here, I can say that it's nullable, but the compiler already knows that, so I can just remove that type system there, that type declaration. Okay, so now all of this is pretty basic, right? But remember, once I'm done with this memscope stuff, what's going to happen? Well, I've opened up a file here. Something needs to remember to close it, because we don't want the program to exit for some reason without closing the data. So what I want to do is I want to do this work here, and then finally, again, a very nice high-level thing. Finally, let's close the file, right? Very easy to do, and yet this is still a very low-level, very fast language. And then finally, I'm going to return those lines that we created, okay? So I no longer need this. This is my function. Let's go ahead and run this code, okay? I'm going to run it and see what we get. This will take a little bit longer to run because it's compiled code, but still. Compiling. Come on. Compile. Oh, did it already go? No, it's compiling. Give it a second here. This part's the worst. It's the waiting. This is not as fast as on the JVM, but the result is a native element, a native application. So there you go, hello Kotlin native printed out, and there are the 2 lines of the file. So to give you an idea of what I mean, if I go to the desktop here, hello native, I think, no? Hello downloads, cd hello native, build, bin, native. Okay, there we go. See how fast that is? Native code, I could do that all day long. And also the whole application is 1.6 megabytes. And that's Kotlin, right? It's a really, really nice experience. Even if you wanted to write native stuff, you could do like operating system extensions. You could write plugins for Finder or Internet Explorer or Windows Explorer or KDE or GNOME or whatever, right? Really interesting opportunity here. And that's just one, okay? But for me, so far we've seen Android, we've seen Gradle, we've seen native code, right? But for me, the most interesting opportunity is on the server side because there's so much business logic there. There's so much code that's important to get right. And so what I'm going to do is I'm going to go to my second favorite place on the internet. Come on. I'm going to go to my second favorite place on the internet. Start. Start.spring.io. And what we're going to do here is we're going to build a brand new application that takes advantage of Kotlin. We're going to build a new service, and we're just going to call this Basics. And this application is going to use the Kotlin language. It's going to use regular old APIs, libraries that have been around forever. I'm going to use Postgres. I'm going to use JDBC. And that's it, I think. I'm happy with those selections. Maybe I can build a web endpoint, a regular Spring MVC endpoint, and so on. But these are old APIs. JDBC, Postgres, come on. This has been around for 20 years, right? And I'm using Spring, which has been around for 18 years. But I'm using it with Kotlin. And already we get some benefits. So let's go ahead and hit generate and then open this up. So UAO basics. Start the application. Let this start up here a second. Loading. Can you see Mario, the Super Mario Brothers? There, loading. Oi. Basics, Maven install. Okay, so there's our brand new project, our brand new application, and all we're going to do in this application is just talk to a SQL database. Now, I have a SQL database. I have Postgres, the SQL database, running on my local machine here, right? So brew services, start PostgreSQL. Okay, that'll be running in the background. Okay, so PSQL-U, orders, right? There we go. So we've got all this stuff. Now, what I want to do is I want to talk to this database, and I'm going to do so by creating a little interface. So here, I'm going to create a customer service interface, and this interface is going to have one method. It's going to return a collection of customers, and obviously this is just an interface. I need an implementation, and I also need a data object to describe the data in my customer table. So I'm going to create a class just like normal, just like you'd expect, right? The problem is that this class, it has fields, right? It has a private val ID, and that's an integer, or an int in Kotlin rather. And that could be, you know, it could be nullable. So there's that, right? I want to make that private late init. I could do something like this, right? It's also mutable, right? I could do that. So val, whatever, or private var. There you go. That could work, right? Something like that. It must be initialized, so I need to provide a constructor. And what I'm doing is I'm going to create a constructor here, private ID, you know, it int, and I can say equals it. There you go. And you can see this is very redundant, actually, right? Very redundant to have this field. And I could also create some, you know, properties, right? I could create some getters and so on, like this, int equals this, or I could do the Java way, or I could say return this.id. And so on. Do you see the problem here, though? First of all, the ID is nullable, so that's not good. Second of all, I've made the field var, and that means that it can be changed later on. It's mutable as opposed to final. I suppose it should be final or not final. That's the right definition. So I want a set ID maybe and an int there, and I want to say this that ID equals ID. And now I've got kind of a Java-like thing, but this is the waste of space and time and mental capacity. Kotlin makes life a lot easier. Think about what I'm trying to do here. I still haven't even gotten my toString or my equals or my hash code or whatever. What I want is each, an object to have a class that have on a class that has an object that has fields and a constructor to assign storage to those fields. And I want getters and setters, or at least getters if it's immutable. And I want toString and equals and hash code to work. Well, Kotlin has a very nice syntax for all that. You just drop all this, and then you use property syntax. You use the property syntax for the constructor. So val ID is already going to create, when I run this code, it'll create a class that has two fields. One is of type int, one is of type string. The constructor will take two parameters, and the class will have two getters, so customer.getID, customer.getName, and that'll automatically work. If I want it to be mutable, I can say var, in which case the class will have get and set, for the respective fields. Now, I still don't have equals and hash code and all that stuff. So in order to take advantage of that, because this is still a class, I could still have a function here. I could still say do something, right? This is very convenient. But if I'm just trying to have a class that assigns state to fields, and I want a record basically, or a case class like in Scala, I can just do this. Just say data. Okay, so now I've got my basic interface. I've got my interface and I've got my class, and I want to create a JDBC customer service. And I'm going to implement that interface, customer service. And this interface is very simple. It's going to have an all function that I'm going to call back. And by the way, notice that even though I sometimes make the mistake of calling these methods, they're not methods in Kotlin. We call them functions. You have functions inside of classes, and you have functions outside of classes. If they're inside of a class, they're called a member function. They're a member of the class. If they're outside, they're just called functions. You can call them methods. We all know what you mean, but technically, they're called member functions. I don't care, but just so you know. Okay, so what we want to do is we want to create a bean, an object that Spring will manage for us. So we're going to make this a service, and we want Spring to give us a reference to a JDBC template. Now, the JDBC template is an object that's been in Spring for 18 plus years. It's a very useful object, and it makes it trivial to talk to existing SQL databases. So I'm going to create a method here. I'll say JDBC template.query. Make this a little bit less verbose so I can fit everything on the screen. JDBC query, select all from customer. Okay, and what I have here is a string and a set of parameters that I want to pass in, perhaps, and then I need to have some way to map the results into an object. Well, consider what the parameter suggests. It's a row mapper, right? Row mapper of type customer, like so. Okay, and then here I have to return a customer. So I'm going to instantiate a customer. The lambda takes a result set and an index that shows you the offset relative to the start of the results. So here I'll say result set dot get int ID. So I'm getting the data from the SQL database. Okay, dot get string name. Okay. Not bad, right? It's okay, and this is partly because of Java's, because of the clean functional interfaces in the Java ecosystem. Okay, so we can make this a little bit better. You saw there's already one opportunity. I could get rid of this parameter since I'm not using it. Just use underscore. That's a convention. This type, this is not required here, right? I don't need that. Kotlin can understand what it is. But going even further, look at this. I've got a lambda. And this lambda is the last parameter in the function. Well, if it's the last parameter, or if it's the only parameter, then Kotlin doesn't care if you hang it outside of the lambda, okay? So this is already very interesting. What did I do here? Return. Oh, right. So there you go. So now I can just leave that return value outside of the function. Okay, not bad, right? Now it's like a block in Ruby, and this you get this for free. This is nothing to do with Spring, but what if I wanted to do a parameter? What if I wanted to say, where ID equals this, where it's a question mark, and I want to pass in a parameter or something like that? Now we've got a problem, you see? In the Java API, right? In the Java API, if I look at the signature here, the function that normally does this has a string, then a row mapper, and then arguments, right? So I'm looking for one that kind of maps what we're trying to do. This one right here. String is this one where my cursor is. It says string, then row mapper, and then arguments. And the reason is because if you have a variadic array of arguments, those live at the end of the function. Well, in Kotlin, the end of the function, the end of the function is where we put the lambda, because we want that to live outside of the function. So I can't do that. It has to be some other way. So what Kotlin gives you is the ability to bring in extension functions. See that? Whoops. Yeah, I just imported an extension function. If you command click on that, you'll see that we're in a separate code page called JDBC Operations Extensions KT.class. This class is not part of the core original Java JDBC template type. It's actually a separate code page with functions that get compiled into the original type automatically at compile time. This JDBC Operations Query method is added retroactively onto the JDBC operations. It's only visible, it's only accessible and usable for those of us like you and me who are using the Kotlin API directly. We're using it from Kotlin. So here it's been adapted to be more natural for Kotlin users. String, okay, good. Then the variadic array, and then a native function. Look at that. It's not even a functional interface. It's actually just a top-level type that is a function of type SQL result set Kotlin int to T. Okay. So now we have this extension function that makes the experience even nicer. What else can we do to make this simple? Well, in Kotlin, if you have a function and then the first line is just a return, you can drop this ridiculous extra parentheses, right? That's the same thing, basically. It's the same thing from the perspective of the language, right? So the equal sign is like an inline return. Very, very convenient, okay? So now let's run this. Let's test out that code. I'll create a little component just to exercise the business logic that we've seen there. At component class runner, okay? And now it's going to be a bean, and I'm going to create an event listener. Application listener event. Okay. Application ready event. Good. Alrighty, fun begin. Thank you. So there we go. This is my runner, and it's just going to be a listener for when this application starts up. And I'm going to inject my JDBC, my customer service implementation, right? I've got an interface. I've got one implementation of it using the JDBC template. So let's just try that. Customer service .for each. Line hello it.id it.name, right? Same thing. Okay, so now I can run this code. Let's see what we get. Okay, so I forgot to specify the query, the connection string. So Spring JDBC Spring data source URL. It'll be JDBC Postgres localhost orders. Okay, and the username orders, and the password, of course, orders. Okay, 2. Didn't I already have? Postgres, yeah. PostgreSQL maybe. Sometimes I get this wrong. Let's try the string here. Okay, column index is out of range. Range 2, number of columns 1. Okay, so what I'm going to do is I'm going to go back to my code, select all from customer where ID, oh, we don't have this, we don't want this, we don't want this, or that, or these arguments. Okay, 2. There we go, hello, etc. So I've got my users now. Okay, so this is a very simple traditional application, but one of the things that you can do when you move to a new language, and you should do, is to take advantage of the ecosystem in that language. So now I'm going to use a different library called exposed, okay? And we're going to use this ORM library from the Kotlin ecosystem. It's not available to people in the Java ecosystem. This is one of those things that's just been developed by JetBrains, and it works very nicely with Kotlin-based applications. And it's also integrated nicely with the system. So I'm going to go back to my build here. I'm going to paste this dependency, and there's exposed. And in order for that to work, I need the Maven repositories as well. So let's get all of that and paste that at the very bottom here. Okay, so now I've got my repositories for DL, bin tray, exposed, blah, blah, blah. A couple things, by the way, when you look at this build, notice that the Spring starts.spring.io has already created a project for you that has the Maven plugin. It has the default dependencies that you needed there. It has the support for Kotlin runtime here in the code, including for reflection. All that good stuff is there out of the box, right? So now you just have to write code. That's all you got to worry about. You can see we've even gone out of the way to configure out of the box some very interesting default plugins that, again, speak to how pragmatic the team is. The default behavior in a Kotlin application is that when you have a class, that class is effectively final by default. Well, with the Kotlin Maven All Open plugin, we make it so that if you are using a Spring annotation like service or component, then those classes are open by default. They're not final. This is useful when you're building Spring or JVM-based applications using something like Spring or Hibernate or whatever, where subclassing is very important. So we can, this is, again, something where the team working on the language worked with us to make this the best experience for Spring developers. Even though the language has a default behavior, the language is flexible. So we were able to undo this one tiny little behavior for the benefit of the ecosystem. Okay, so there's my exposed API. And the way exposed works is you create some sort of configuration to map your objects to the table, just like I did with SQL, but I don't want to write SQL. So what I'm going to do is I'm going to write a configuration object, but it's only going to exist once. I don't need to recreate it. It's only one time. So there's a syntax that you can use in Kotlin to create a singleton. It's called object. So this is going to extend table, and it's going to be a exposed, okay? And I'll say big int, oops, or int, let's try that. Okay, integer dot primary key. Okay, deprecated now apparently. So there's that, and then I have a name field. Name equals var car name 255. Okay, that's my basic definition. And now I can use this automatically. I can use this in my exposed service. The only thing that's important is that I want to enclose the life cycle of my data within a transaction, and that's required for exposed as well. So Spring has this concept called @transactional. You just use @transactional, and then everything, it just works. It's automatically mapped to exposed. We don't have to worry about how it does it. It just does. So here we can say customers.selectAll.map. And map, notice that I've got a result row, an RR. Well, I need to create a custom object out of that, kind of like I did before. Well, I can use it. And here, notice that I'm indexing into the array, or into the object, into it, the result row. I'm indexing into it using my, using this custom operator. Kotlin has operator overloading. So now here's my new implementation of the customer service exposed. Now if I run this, restart. Oops. Customers. Oh, the table is different. It's called customer. So I need to call this customer, right? It's using customers by default. I don't want it to, it's customer. Restart. Okay, so there you go. Now it's returning the data using exposed. So you can see using the ecosystem, the basics of the ecosystem makes your life better. And even using old Java ecosystem libraries makes your life better. So in both cases, I think you're ahead. But where I think we really gain a lot by using Kotlin is when you look at it for the purposes of DSL. So what I'm going to do is I'm going to bring in my reactive non-blocking web support. So this is kind of like Node.js. It's going to create an event loop where we will not keep open any sockets while we're waiting for bytes to move across the wire. We're going to be able to just ask for the data and then jump off that thread and relinquish the thread back to the thread pool, and then something else will use it in the meantime. So it gives us much better scalability. Okay, so this is very different from JDBC. We're going to be using something called R2DBC. Okay, and so here we've got a number of different APIs. It's Kotlin. I'm using the latest and greatest version of Spring Boot. Let's hit generate. Okay. CD downloads, UAO. Well, so first of all, unzip DSLs. Save and install. Okay, installing. Okay, good. So now pom.xml. Open this up in the IDE. There's my application. And in this case, we're going to connect basically the same way that we did before, but we're going to use a different framework, a different library for connecting. So we're going to use R2DBC Postgres, not QL, localhost orders. And then we're going to create a username, orders, and then a password, orders. Okay. So there's our connection string. And here, I want to create a repository. So I'll create a customer repository to handle the tedious data manipulation lifecycle. Well, of course, I'm going to use the reactive CRUD repository. And this is going to handle boring read, write, update kind of logic. This interface needs a pointer to a data type, or a reference to a data type, and a primary key type. And the primary key type, of course, in this case, is an integer. So that's it. That's the basic entity there. I'll signal that this is an ID using @ID. Okay. Now that's the basic data access logic using Spring Data. This is much more high level than the low level exposed and so on. And so now what I want to do is I want to write an application that creates an HTTP endpoint. And I can do this using the functional reactive HTTP style. So bean fun HTTP routes, router function of server response. Okay. And here I'm going to return a server response route dot build dot get / customers. And my job here is return a handler function that returned a server response. Okay, so I'm just returning, it's like express.js or Sinatra or Scalatra or whatever, right? Lots of different examples here. And in order to do my work, I need to inject a reference to the customer repository. That's what this is right here, CR. So I'll say CR.find all, and I'm going to provide a class literal for the second parameter. And that's basically it. That's the Java version of this API. And that works, of course, but can we make it nicer in Kotlin? Well, I think we can, right? First of all, obviously, this could be removed. This could live outside, right? That's better. But we can go a step further. There's actually a DSL in Spring. We have all these extension functions, so I can actually say return router and just do that. Isn't that nice? I can say router. Good. And there's my HTTP endpoint. Very good. But here's the thing. I'm using Java configuration to register these beans. Basically, when you want to register a new object, you have to register a new method. But there's also a functional style that you can use here. You can say val bean definitions equals beans. Right? That's a VSL. And here you define one bean. But this is just a function, so I can do, I can do anything that I would normally do. I can say if math.random is greater than 0.5, then and only then should you register this bean. Right? It's inside of the if statement. Basically, it's a condition. I don't know if you'd want to do that, but you could. Is my point. You're calling this bean as a function. It's not a method or a function on a class, right? And so what am I doing? I'm going to register a bean. The type of the bean is router, router function of server response, and it's a router. So I'm going to just take that, all of that, and return that there. In order to do my work, I need the repository. I need the reference to the customer repository. So I'll say equals to ref customer repository. And the reason I can do that, look what I've just done. I've said to Spring, use this generic type in this function invocation and find all the objects at runtime that have this class called customer repository.class. Well, you can't do that in Java, right? You can't capture the generic class. There's no way to say this is a generic parameter t, and I want to create a new t.class. You can't ask for that in Java. But at Kotlin, we have pseudo or somewhat reified generics. And the way that works is you see this function here, public final inline reified ref. So t is reified. We have the ability in our code now, because this kind of acts like a macro. It copies and pastes the code at the call site, in the definition to the call site. And so you can say, give me a new t.class, right? And you can do reflection on that and so on. Well, that means that we don't have to do this, right? We don't have to. The compiler can give us that information with just the generic type. So this is guaranteed over here to be what we want, right? Customer repository, right? And that's actually redundant. We don't even need to specify that. So now I've got this endpoint. I've got this bean definition. I'm assigned the result to that. And I want to assign this. I want to add initializers. Okay. Bean definitions. Good. Okay, so there's my endpoint. Let's create one more endpoint here. Get /customers /ID. Okay. And here, I'm going to do something kind of interesting. I'm going to produce a single result back. Find my ID, and I'm going to use the request. That's the implicit request. I'll say it.path variable ID val ID. I'm going to do integer.parse. You've seen this before, right? Parse int. That's just an int, so I'm going to pass that into there. And there we go. There's my reactive code. Now, okay, can we do better? Look, remember I just said we don't have to have these class literals? Well, that's true, right? Thanks to extension functions, there's a Kotlin API we can use instead. An extension function. Look at that. Much nicer, right? Same thing. So in both cases, we're using the reified class literal to get the result. I'm looking up a single result and so on. And everything seems fine. Let's go ahead and comment out all of that. And let's see what we get. Localhost customers. So we've got some customers. Let's go to customer. Okay, go here to this one. There's one particular result. Okay, so that's working fine. Good, right? Very, very nice. Very nice DSLs. Okay, can we do better? Well, something's very interesting here. Well, what I'm doing is I'm using these reactive APIs, these types. You see these functions here? They return something like a mono or something like a publisher or a flux. These are kind of like really, really, really smart completable features. Just that's all you need to know is they're asynchronous and they return data, okay? But in order to use them, you have to chain together method invocations. Maybe that's not for you. Maybe you don't want to do that. Well, one of the nice things that's available in Kotlin, but not in Java, is this idea of a coroutine. And with coroutines, you can write code that feels like it's imperative, but it's actually not blocking the threads. It's actually freeing up the threads. So by ID, this is actually right now a customer, right? A mono of customer. This single result I got back here, right? So I'm going to say import this. So that's actually what I've got right here. So I've got a coroutine of customer. I've got a mono of customer, a publisher kind of, or a completable future of customer. But that's, in order to do something with that, I have to subscribe and I have to resolve the value. It's not the value itself. Well, wouldn't it be nice if I could use imperative style syntax? Well, with Kotlin, like I said, we have this thing called coroutines, and Spring supports coroutines. And in fact, all this reactive stuff that we're talking about here, all of that is the foundation for our coroutine support. So all you're going to do is swap out the coroutine router. And then here, I'm going to say, I want to await the result. Okay, await first. And in this case, I now just have a customer. So I'm going to get the results, but I'm not blocking. I'm not actually sitting on the thread waiting for something to happen. The thread is going to finish. It's going to go back to the thread pool. This method will exit. Then the rest of the execution logic will be wrapped up in a continuation, and that will be invoked as soon as this value is real. And so I can say body value and await, right? So there's my coroutine value. See how nice that is? I just have to body and await, find all, and then turn this into a flow. Okay, so there you go. There's my coroutine capable code. And you can see already it's simpler to understand. There's no method chaining. I just have a customer. Of course, I asked for a customer, I got a customer. The fact that the compiler stopped the function and paused the thread and returned it to the thread pool and all that behind the scenes, I don't have to worry about that. It just works. So same as before, right? There's this and there's this. All right, my friends, thank you so much for being here today. I am sorry that we got off to a late start. Here we are, 60 minutes exactly. I appreciate your time. I know that there are a lot of places that you could be right now with your family, somewhere else, anywhere, and you decided to stay with us today. That's very kind of you. I wish I could be there in person. You know, I've always wanted to go. Unfortunately, the closest I've ever gotten was to Malaysia, and I've heard so many good things, and maybe next year I can join you in person. Thank you so much for asking. I'm happy to answer questions.
So Josh, we have some questions here, like a question here for you. So the question is posed in the tab under Q&A. So it's by Xin. She's asking that where would you use Spring versus Spring Boot?
Hi, so Spring Boot is an opinionated approach to Spring and to the larger Java ecosystem. So today, if you wanted to build an application and have some things just done for you automatically, kind of like Ruby on Rails, then Spring Boot is the right way to go. I would start every project in the last 6 years with Spring Boot. I would never use Spring directly anymore. You still are using Spring when you use Spring Boot. You can still provide dependency injection, you can do all that stuff. But what Spring Boot does is it says, hey, look, there's a large category of things that you could do yourself. For example, configuring a database or configuring a message queue or a cache or something like that. But since it's very common to do this, and since everybody does this, let's let the Spring team do it for you. Right? So it's kind of like pair programming with the Spring team. You let them do this boring work, and then it'll give you common defaults. So in my case, I showed you the code talking to databases. You did not see me configuring the data source. I configured 3 little property files, 3 little property values, and that's it. And then Spring Boot said, oh, I see. I know what you want. I'll create a data source, and I'll make that available to your code, and I'll create the Jdbc template, and I'll create the connection factory, and all that stuff is just done for me. And that's all because of Spring Boot. So Spring is kind of like if you want to build a car, it's like if somebody gave you all the components to build a fast, Ferrari or something like that, right? A really fast car. Somebody gave you all the components and put it on the table and said, here, there's your Ferrari. Just assemble it, right? And it's fine. You can definitely build a Ferrari with Spring. But with Spring Boot, it's already pre-built. All you got to do is drive, right? We take care of all the assembly for you, so you can focus on writing the business logic. I hope that helps.
Yeah.
And check out start.spring.io and spring.io guides, spring.io /guides. Lots of great tutorials there. They're quick too.
Thanks for the explanation, Josh.
Thank
Let's
you.
see if anyone else has any more questions. You can post it in the Q&A tab.
And I appreciate the question, by the way. It's a very good question.
Maybe while waiting, do you want to share any more tips for people to move? Because I know that not a lot of people here in Brunei use Kotlin. And I think
Yep.
because even in our university and college levels, we are taught still in Java. So maybe I know,
Oh,
yeah.
So again, I expect the very large majority will speak and use and work with Java. But Kotlin is a very interesting language because it's growing so much. So, and if you understand Java, then you've already got the skills to write Kotlin code on the server side using Java, using the JVM. But once you understand Kotlin, you can also take your skills to mobile, and you can take it to native code into the browser, so that one language gives you, it opens a door to all these other communities. So for me, I wish that they would teach Kotlin first at universities, because I feel like with Kotlin, you are asked to forget or to unlearn a lot of the things you have to learn with Java. Java is fine. It's a great language. I use it all the time, and it's getting better every day. Java 15, wonderful, right? It has multi-line strings finally. Every other language has had this for decades, so finally Java has it. But on the other hand, Kotlin's much further ahead in terms of syntax because it's brand new. It's only 10 years old, 11 years old. So they were able to erase some of the mistakes, Are there ways to transfer existing Java applications to Kotlin and Spring Boot? Well, it depends on the kind of application. If it's a Spring application, then yeah, of course, you can transfer to Spring Boot because every Spring Boot application is a valid Spring application, right? So you can take any Spring application and usually just remove some code, and you'll get a valid Spring Boot application, right? As for Kotlin, well, the JetBrains folks, the engineers and the wonderful people at the JetBrains team who make IntelliJ and so on, they have a bit of a nice trick that they put in the IDE. If you copy and paste Java code into a Kotlin project, it'll convert it for you into Kotlin. It'll paste as Kotlin. So you copied it from your GitHub in Java, and then you paste, and suddenly, oh, my Java code turned into Kotlin. What happened, right? So it's super easy to get your code into Kotlin. Getting it back out, on the other hand, not so easy. Unsurprisingly, it's not possible to go from Kotlin to Java with that ease. But I think that's fair, right? Because Kotlin, you can express this many paradigms. With Java, you can only express this many. So you're widening the possibilities there. So yeah, getting your language, I'm not saying that the code that you get when you copy and paste is perfect, but it'll work, right? It's a good start, and you can fine tune it and remove some stuff. It's valid. The other thing that you have to understand is that Kotlin, because it's on the JVM, in this case, I also showed you the LLVM native code earlier, but in the case, if you're using it on the JVM as we are here, then I can link to anything. I can add any library that's Java-based to my code and use it from Kotlin, like I just did, right? Most of Spring is still Java, but we have certain extension functions. So you can take existing code, and if all you're trying to do is to reuse existing stuff, you can add them, you can link to them, and also you can have them in the same source directory. You can have source main Java and source main Kotlin. That's a valid, very common configuration. So you can have a code base that cross-compiles both Java and Kotlin at the same time. So types can reference each other and so on. So it's pretty easy to do that if you wanted to. I hope that it helps a little bit.
Thank you for the answer, Josh.
Thank you for the question. Great question.
So far, those are the only questions that's been posted. I think you did share your email as well as your social media handles for people to reach out to you as well, right? And
yep,
you have your podcast every Friday.
I do. That's today. So it went out last night. About 20 hours ago, the episode went out. This week I talked to Dan North. He created BDD, behavior-driven development, the idea of, given, when, then. If you've ever written a test like that, you're doing BDD. He created that. He's a legend, right? He's great. You should listen to him talk. It's great. Me, I'm an idiot, but him, the guests I have on the podcast, they're awesome. They're so awesome. So I love that.
We'll be sure to check that out as well. Okay, I think since no one else has any more question and answer, we really appreciate your time and your talk, Josh. It's really great. Okay.
I hope we meet again. Thank you so much, everybody.
Thank you so much.
Have a great year.
You too. Stay safe.
You too.